Today we're talking about the area of quadrilaterals, and of course that includes parallelograms, all different types of parallelograms, including rhombuses, rectangles, and squares, and it also includes trapezoids. We're going to start out by talking about parallelograms, and parallelograms have what's called bases and heights. The bases are the sides opposite each other that are parallel to each other. So bases are sides that are parallel to each other. Bases are sides that are parallel to each other. And there's actually two pair of bases. There's two pairs of bases, the top and bottom, and the two sides form two pairs of bases in a parallelogram. The height is the perpendicular distance between two bases. It's the perpendicular distance between two bases. So it's the line that is perpendicular to two of your bases, or one pair of bases. So we see an example of a height here in red, and it's perpendicular to the top and the bottom bases. Here we see a height here in red that's outside of our parallelogram, but it's perpendicular to our top and bottom base as well. Here in our third picture, we see another height that's perpendicular to the top and bottom base. So our formula for finding the area of a parallelogram is to use our understanding of what a base is and what a height is in a parallelogram. So we're going to find the height and the base of our parallelogram and multiply them. And the way we know which base to use is whatever base is perpendicular to our height. Now we'll have two bases that will be perpendicular to our height. We just picked one of them. So the area formula is area equals base times height. So if we want to find the area of this first example, we're going to use that formula, area equals base times height. So the area equals the length of the base times the length of the height. Our base is 4 centimeters, our height is 6 centimeters. So 6 times 4 is 24, centimeters times centimeters is centimeters squared. You really don't want to leave your units in your problem when you do your math. However, I wanted to show you how you end up with centimeters squared mathematically. The other thing to keep in mind is that two dimensions will always be units squared. So let's look at some more examples. Next, we're going to talk about trapezoids. Well, first I want you to understand where the trapezoid formula came from. The trapezoid formula is based on the formula for the area of a parallelogram. If we look at this parallelogram, when looking at a parallelogram, you can split a parallelogram into two congruent trapezoids. And what you'll notice is that the trapezoid has two sides that are parallel. We already know that for the definition of a trapezoid. Well, the two sides that are parallel to each other are different lengths. And you'll notice that if you look at the other side of the parallelogram, it's the trapezoid split up, turned upside down. So our base 1 in this diagram goes from the bottom to the top, and our base 2 in this diagram goes from the top to the bottom. So the base of the entire figure, of the entire parallelogram, is the sum of base of 1 and base of 2. And we use base of 1 and base of 2 to denote they are bases, but they are different lengths. So that's why we use a sub 1 and a sub 2. The height is the perpendicular distance between the top base and the bottom base. So we know our parallelograms have an area formula of base times height. So the base in this picture is base of 1 plus base of 2 times the height. Well, with trapezoids, it's just half of that. It's half of the area of your parallelogram, but it's going to be base of 1 plus base of 2. So this is the formula for the area of a parallelogram. It's 1/2 the sum of base of 1 plus base of 2, because that gives you the entire base, one side of your parallelogram, times the height. So here is a typical trapezoid. This is actually an isosceles trapezoid, and you can clearly see the two bases and that they are obviously not equal to each other, which is why we use base of 1 and base of 2 as our notation. Our height is the perpendicular distance between those two parallel sides, or those two bases. So this is the height perpendicular to the two bases. In this trapezoid, 14 and 8 are the two sides that are parallel to each other. Therefore, they are the bases. So 14 and 8 will replace b sub 1 and b sub 2. It does not matter if 14 is b sub 1 or b sub 2, and it does not matter if 8 is b sub 1 or b sub 2. Doesn't matter what order we add them in. Commutative property of addition. And then 10 is the length of this leg, and that is not a perpendicular distance between 14 and 8, so it is actually extra information. 8 here is the perpendicular distance between 14 and 8, so therefore it is the height, and we replace it, that h with 8. Then we just plug 1/2 first parenthesis 14 plus 8, second parenthesis 8 into our calculator, and we'll get 88. Make sure to put your parentheses, and you should get the correct answer. This particular trapezoid, the 3 and the 5 are the parallel sides, therefore they are the bases. 4.5 is the perpendicular distance between 3 and 5. 8 and 10 are the legs. They are not parallel to each other, so those two lengths are irrelevant to our problem. So I'm going to replace B1 and B2 with 3 and 5 and replace my height with 4.5. I'm just going to plug this into my calculator, 1/2 parenthesis 3 plus 5 parenthesis 4.5, and I'll find that the area is 8. When looking at the area of rectangles, rectangles are a type of parallelogram. So I could just use the formula area equals base times height to find the area of any parallelogram, including a rectangle. Well, we know from elementary school that we use the formula area equals length times width. The reason that we use that formula is that the length and the width are the base and the height. Because of the fact that a rectangle is made up of 4 right angles, we know that the width is perpendicular to the length, therefore the width is the same thing as the height, and the length is the same thing as the base. Or you could twist it around and look at it the other way around. The length could be your height and the width could be your base. Doesn't matter. So we can use either area equals base times height or area equals length times width when we're working with rectangles. Whichever you feel comfortable with is fine. So let's find the area of this particular rectangle. The area is 12 centimeters squared because you're going to multiply 3 times 4, and that gives you 12. Centimeters times centimeters gives you centimeters squared. So mathematically, that's how you come up with centimeters squared. We also know that if we have 2 dimensions, our units will always be squared. You don't need to you really should not put your units in your problem as you're working it out. I just want to show you guys where centimeters squared comes from algebraically. Squares, we know, have all the same lengths for all the sides. Therefore, the base and height will always be the same. So we can use the formula area equals base times height, but what is more frequently used is area equals side squared, since we know the sides are congruent to each other. So using the formula area equals side squared, what is the area of the square? So the area is 5 squared, or 25 inches squared. Here are all the formulas that we should know by now. The area of parallelograms is base times height. Area of squares is s squared. And now you could also have area of a rectangle is length times width, or you can just remember base times height. Area of a rhombus, base times height. Circles, area equals pi r squared. Circles circumference equals 2 pi r, or pi d. Trapezoids, area of a trapezoid equals 1/2 times the sum of the bases times the height. So when we're working with quadrilaterals, we're going to do some examples here. We always need to keep in mind that bases are sides parallel to each other, and the height is the perpendicular distance between the two bases. We're going to find the area and perimeter of each parallelogram. The area to number 1 is 6 times 4 because they're perpendicular to each other, which is 24 centimeters squared. The 6 does denote the entire bottom line means 6 centimeters, not just part of it. The perimeter to number 1 is 22 centimeters. Perimeter for our parallelograms, well, for parallelograms and rectangles is 2 times the length plus 2 times the width, and this is a formula you should know. So we're going to multiply 2 times 6 plus 2 times 5, and that gives us 22 centimeters. So the perimeter for our rectangle It's base times height, or length times width, whichever you'd like to think of, which gives us 60. Our perimeter is the formula 2L plus 2W, which you do need to know. So that's 2 times 10 plus 2 times 6, which is 32. This is a rhombus. All sides are congruent, but we do not have all angles congruent. So the area is base times height, which is 5 times 7, which is 35. So the 7 is the height. It is not the length of a side. So when we figure out the perimeter for any four-sided figure that has all sides congruent, the formula for the perimeter would just be 4 times the length of one side, or 4s. So 4 times 5 is 20. So the area for a square is base times height, or side squared. So you get 9 squared, which is 81. The perimeter is going to be 4 times the length of one side, since all the sides are congruent and there's 4 sides, and 4 times 9 is 36. For each of these word problems, you need to write down your formula, substitute what you know in the place of the variables, and then solve using equations. For number 1, I'm going to write the formula area equals base times height, since I'm working with a parallelogram. I'm going to substitute 16 in the place of A in my formula, since that's the area. And I'm going to substitute 8 in the place of B, since that's my base. I'm solving for the height, h. So I'm going to divide both sides by 8 in order to get h by itself, and I end up with h equaling 2 centimeters. So for number 2, we know the area of a square is 144 centimeters squared, and we know that for a square, the formula is area equals side squared, or s squared. So I'm going to substitute 144 in the place of area, so I get 144 equals s squared. In order to solve, I'm going to take the square root of both sides, and I end up with s equaling 12 centimeters. It's the length of a side, so it's just centimeters to the first power, since it's just length. In this problem, we're working with the trapezoid, so we're going to use the formula area equals 1/2 the sum of the bases times the height. We know that the area is 200, so we substitute 200 in the place of A. We know that the two bases are 75 and 85, so we are going to add those in the parentheses, and it doesn't matter what order we put them in. Next, we're going to simplify. Make sure you use your order of operations and add what's in parentheses first to get 160. Then you need to continue simplifying that right-hand side of your equation. Half of 160 is 80. Now we have the equation 80h equals 200. We're going to divide both sides by 80 to get h by itself, and we end up with 2.5 meters.